Hello everyone, this is Shreya Bose. I am a data science and business analytics intern in the Sparks Foundation. I am a part of DRIP October 2023 batch, and today I'm going to share with you my task on prediction using decision tree algorithm. So, firstly, the task that has been given to us is to create a decision tree and to visualize it graphically. Also, the purpose of this task is to feed new data to the classifier and just see if it can predict the class correctly. Now, before we begin to the details of how I have done the coding, let us understand what decision tree actually is. Decision tree is a supervised learning model. It is used both for classification and regression, but mainly preferred for classification problem. The dataset that we have been given has a classification problem, for which we have to understand some of the main basic things that the decision tree uses. The first thing is the root node. Now, root node is the topmost node in the tree. The decision tree is a logical tree structure. It has root node, which contains the most important decision making process, and from there, the different nodes, which are called the internal nodes, branch out. We'll be seeing it visually, and I'll be explaining you over there in details what is called what. So, before that, let us get an overall review of it. So, then there is a terminal node. It is a node without any child node that indicates a class label or a numerical value. Then there is splitting. Now, what is splitting? Splitting is the most important process over here. It is a node is divided into two or more subnodes using a split criterion and a selected feature. A subtree is a subsection of the decision tree that starts at an internal node and ends at a leaf node. Parent node is a node that divides into one or more child nodes. And the child nodes is the one that emerges from a parent when it is split. Now comes the most important part, that is the impurity. Now, each and every data has some or the other impurity. Now, to understand the randomness of the data, we have two things over here, the Gini index and the entropy. These are the most commonly used features used in decision tree. Now, using this, we find the information gain. It is the measure of changes in entropy after segmentation of a data set based on an attribute. So, firstly, we select an attribute on basis of which the decision has to be made, and then we do the segmentation, and then we calculate the information gain. Now, it is important to remember that a decision tree always tries to maximize the value of information gain. And a node or attribute having the highest information gain is split first. How do we understand which of the node or attribute has the highest information gain? It is done using this formula. Now, while we are coding in Python, we don't need to know the formula because we don't type it over here. We use directly the packages. But then, if we don't know the background working, the whole idea of predicting using decision tree is incomplete. So, entropy is a metric measure to the impurity in a given attribute. It specifies randomness in data, and Gini index measures impurity or purity used while creating a decision tree in the classification and regression tree algorithm. Now, I'm sure you none of you would have understood it if I'm because I'm just reading through the theory. Let's put it into practical use, and I'm sure we'll be able to understand it in more details. So, firstly, we'll be importing the data, then analyzing it, trying to find the accuracy of the model using decision tree. This is where even the visualization occurs. And then we'll try to predict the newly added data. So, firstly, importing the data. So, I have imported pandas, numpy, matplotlib for plotting. Then there is the most important decision tree and decision tree classifier. Then there is cross validation score, Seaborn, and so on. Now, we the data given to us was iris data. Now it is a very common data. So I have imported it using read CSV. It was a CSV file. You can see it out here. I have already downloaded it. So let me run it again and show you. So data is imported successfully. Now there we are going to print 10 dataset, first 10 datasets, and as you can see, it has the information that it has ID, sepal length, sepal width, petal width, and the species. Now let us analyze the data. So we calculate the number of rows and columns we get to know from the shape function. So the data frame name is over here df, as you can see. So I'll be using df.shape to understand what is the rows and columns, as well as I'm calculating if there is any null. So the data is very clean as there is no null over here. And now I'm calculating the values based on species. So let us see how many species are already there. So we can see there is Iris setosa, Iris versicolor, and Iris virginica. Now I have tried plotting them in a graph. Uh, Now the next is plotting them in according to the four criteria that we have, four attributes that we have seen: sepal length, sepal width, petal width. So sepal length, when regardless of the species, it is calculated and put in together. It shows this sepal width, petal length, and petal width. Now this was a very basic EDA that I have done, the exploratory data analysis. So let us go ahead and find the accuracy of the decision tree. Now, firstly, what I'll be doing is dividing the data into X and Y. Now, X is the attributes, these are the attributes, and Y is the classification that I need to do. So, Y is the result, which means if I enter all these values of X, then I will be getting a species as the value of Y. So, these are called X values, and this is the Y value, which means Y value is the attribute which you want to predict through the model. So over here I've taken sepal length, sepal width, petal length, and petal width as X, and I have like just divided the whole data set into two halves. Then Y is the species. Now, regressor is a variable which calls decision tree classifier. Here we are classifying into three different categories of species. So hence classifier is called, and the criteria I'm choosing is Gini. Now I'm fitting the data X and Y into the classifier, and over here I'm trying to shuffle it because shuffling is important. Then I'm trying to print the cross validation score where I'm sending the regressor X, Y, and the shuffling and multiplying it with 100 because the mean is always comes in point. So I need to multiply it with 100, and I'm getting this as my value. Now this is quite a good value. So let us see what the accuracy is. So accuracy, when we are trying to calculate using score, where I'm sending again the X and Y value, I'm seeing the accuracy is coming 100%. That is because our data is so clean uh, and the model is so perfect that we are getting 100% accuracy over here. Now, since I have done this, let us go forward with the visualization. Okay, give me a minute. It's not going to come together in the screen. So let us take it in half. Okay. So over here, what happens is petal width, I'm sending the feature names over here, the four features. The class name obviously is Iris, and figure size is 25 and 20. So automatically it takes the petal width centimeter as the decision, the root node. From there, we are getting two nodes. This is the internal node. Why? Because from here again, decision is taken, and again it is splitting into two halves. So firstly, we are checking petal width less than equal to 0.8, and the samples are 150 as we have already seen. 50, 50, 50. There are three species, and the Gini index is this. So again, it is divided into two halves, where we can see the Gini is 0, so it ends here. And the petal width, again, we are checking from here. If it is less than 1.75, we are increasing the range over here. It was 0.8, Now it is 1.75. And from here again, it goes into two halves. If it is less than equal to 4.95, then again two halves. Over here, less than 4.85, then again two halves. And it goes on. It goes on till I reach the Gini index 0. Again, Gini index 0, Gini index 0. So samples here are 3, value 003, class is I. Now after this classification, let us try with the criterion entropy. It gives the same, is the same. So there is hardly any difference between entropy and Gini over here because the data is so clean. Had it been any other data where we had some impurities, maybe the Gini and this entropy value would have been different. So this is the whole visualization. Now let us do the main thing. Let us try to predict. Now how will we predict? Firstly, we'll be entering four values, four random values, and just checking if this is actually giving us any output or not. So the sepal length, let me give it as 2, sepal width 4, petal length 3, and petal width as maybe 1.5. Okay. So let us see. So it's showing me iris fuzzy color. Now I don't know whether this is correct or not, right? Because I don't know which values it should go. So let us take um, another set of values which is directly taken from the data. Now I already have this data over here printed. So let us take a random data from it. Let us put suppose I'm giving 30. First 30 is printed. Let us take any random data. Okay, let us take this one. 16. Okay. So these are the four values, and my answer should be iris setosa. So let us put these values over here. So my answer should be iris setosa, and I have 100% accuracy. So let us see if this works. Well, it is working. It is predicting absolutely correctly. So this was all about prediction using decision tree algorithm. I hope you have liked it. Please do let me know if I can make any improvements over it. Thank you.